Well, hey there, it's your old pal, Mr. Cook, and we just did a Gaussian elimination with backward substitution problem. Now we're going to do solving using Gauss-Jordan elimination. So it starts out the same way. We're going to create a coefficient matrix from this. So let's see, and then turn it into an augmented matrix. So we've got 1x, 3 y's, 1 z's, and then 8. And then we've got negative 1x, negative 2y, 3z, and a 6. And then we've got negative 2x, negative 5, a positive 3, and then 1. Okay, so here's our augmented matrix. And let's start doing some row operations. So I already love this. This is my pivot row. I've got that 1 right there in the upper left corner. This is like ideal. I'm not touching this thing till the very end, okay? So let's do the Gauss part. By the way, let's have a conversation real quick. Gauss, like, he created this whole system for solving. Like this Jordan guy, he's got the right idea. Okay, what he did was he saw Gauss's thing where he stopped when he got in a row echelon form and did backward substitution, and he was just like, well, you know what? I'm going to keep going with these row operations till I get exactly solved for x and for y. Something called an identity matrix. And he just did that one little step and he jumped right on the back of Gauss's procedure, and his name is forever in math books. So he's got the right idea. He had the laziest approach for making his name into history. I say that, but then Jordan is like an exceptionally brilliant person. But you know what I'm saying. He just kind of piggybacked on Gauss, I guess, for this. Maybe they had come up with this idea separately. Who knows? But I don't know. I thought it was pretty cool. I like that he did that. Anyways, so how will we get, we got to get this in a row echelon form. So we need to turn this negative 1 into a 0. I need to turn this negative 2 into a 0. So here's what we're going to do. We're going to do one step at a time. Let's get rid of that negative 1 first, okay? So how would I do that? I could take row number 1, right? And that first term right there, that 1. And if I just added it onto this negative 1, that would give me 0. So that's what I'm going to do. I'm just going to take row number 1. Because I don't care about all the other stuff. I'm very short-sighted on this. I just want to get rid of that negative 1 right there. So I'm just going to add it on to row number 2 because that will get me a 0 in its place. And I'm going to replace row 2 with it. Okay, so that's how it's going to look. All right, so I do my algebra off to the side. I've got 1 and 3 and 1 and 8. And then I've got negative 1 and negative 2 and 3 and 6. And I'm just going to add these two rows together. Let's see what we get. All right, so I'm still going to have the same first row. That's not going to change. 1, 3, 1, 8. And I'm still going to have the third row because that's not going to change. Negative 2, negative 5, 3, and 1. But man, that second row is going to change up. Let's see what we get when we add them together. So we get a 0 here. 3 minus 2 is 1. 1 and 3 is 4. 8 and 6 is 14. So we get 0, and then 1, and then 4, and then 14. All right, there we go. There's our first row operation, and we did a great job with that. Now let's go ahead and turn this negative 2 into a 0. So I'm going to use this 1, my pivot, and I'm going to turn that negative 2 into a 0. I don't care about all the other stuff. All I got to do is just take that 1 and multiply it by 2. And if I added it onto the third row, it would turn that negative 2 into a 0. Okay, so that's what I'm going to do, and I'm going to replace row 3 with whatever I get. Okay. All right, so here we go. Ready? Next step is, I keep the first row the same, 1, 3, 1, 8. And the second row stays the same, 0, 1, 4, 14. But then that third row, that's going to change. Let's do the algebra for this off to the side. So we take row 1, the whole thing, all of row 1, and we multiply it by 2. So that's going to be 2 times 1, 3 times 2, 1 times 2, and 8 times 2. And then we add that on to row number 3. So negative 2, negative 5, and then 3 and 1. Okay, so we add these together and we get a 0, and then a 1, and then a 5, and then a 17. So 0, 1, 5, 17. All right, cool. All right, we're actually pretty close to getting row echelon form, which is what we would need for Gaussian elimination. Then we're just going to take a couple more steps to get Gauss-Jordan, okay? So here we go. Next, what I need to do is turn this thing into a 0. So I love this pivot right over here, that 1. I'm going to use it to get rid of this one right over here. Okay. And the reason I picked this new row that has like the zeros in front of it is because if I combine these two rows together, I still have 0 no matter what in this column, like, below the 1. That's what I want. I just want like as simple as I can get it, as many zeros as I can possibly keep. And to do that, I'd have to use just these two rows to maintain that. Because like, think about it. If I put row 1 into the mix, I take that 1 and I multiply it by something and add it on these zeros. I don't want that. That like overcomplicates stuff. So just stick with the row 2 and row 3, and you should be good to go. So the way that I'm going to do it is this way. I'm going to take row number 2. I'm going to multiply it by -1, and I'm going to add it on to row 3, and that's going to be my brand new row number 3. And this should put us into row echelon form. Let's see what we get. So row 1 and row 2 are going to say the same: 1, 3, 1, 8, 0, 1, 4, 14. Now row 3 is going to do, we're going through some construction on this thing, so it's going to look a little bit different. Let's do the algebra off to the side. So I have negative of row 2, so negative of 0, that's just 0, and then -1, and then -4, and then -14, and then 1 of row 3, so 1, 5, and 17. Now I add this stuff together, and that's going to give me my brand new row number 3. So I got to remember that I had like some zeros over here. It's still going to be a 0 no matter what. But if I do -1 and 1, that adds up to 0 as well. So the next number that I have is a 0. 5 minus 4 is a 1, so I get a 1 here. And then 17 minus 14 is going to give me a positive 3. All right, so I've got row echelon form. So back when we did Gaussian elimination, here's what I would have had. Are you ready? I'd have the following system of equations. 1x, so x, plus 3y, and this is like from, this equation here, plus 3y plus z equals 8. And then in the second row, I'd have 1y plus 4z is equal to 14. And then 1z is equal to 3. Wait. Z is equal to 3. That gives me a solution, doesn't it? So you could use, if you wanted to, backward substitution right now and solve for, x, y, and z. But we're going to continue to use row operations to do the exact same thing, okay? But I'm just saying that you could use it from here and solve using Gaussian elimination. So now what I'm going to do is use this 1 right over here to turn this 4 and this 1 into zeros, okay? So I'm going to use like row operations to do it. It's actually like pretty easy to do. I'm going to get rid of the 4 first, okay? So this guy first. So what I would do is I would take row number 3 because I have zeros here, so those aren't going to affect anything. So this is like a perfect row to work with to get rid of like those terms in here, because those zeros, like this one and this one, aren't going to affect any of the other numbers that are in these columns. So I'm going to take row number 3, and what I'm going to do is I'm going to multiply it by -4, and then I'm going to add it on to row number 2. Okay, and that's going to be my brand new row number 2. The reason that I do that is because if I take row 3 and I multiply it by -4, I get the following. I get 0 and 0 and -4 and -12. And if I add that on to row number 2, which is 0 and 1 and 4 and and 14, then if I combine those together, then I get the following. I get 0 and 1 and 0 and 2. So translating this into like, an equation, it looks like this. It's 0 x's plus 1 y plus 0 z's equals 2. You see what I've done essentially with this row? I've solved for y. So here's how it looks. Ready? It looks like this so far. It's the first row stays the same. The second row becomes a 0, and then just following this over here, 0 and then 1 and then 0 and then 2. And then my third row stays the same, 0, 0, 1, and then 3. Okay, I'm 2 steps away from getting this completed, but I've run out of space. So what I'm going to do is rewrite this matrix up in the corner over here, okay? Obviously, you wouldn't do that on your test, but you know what? I don't have a lot of steps, so a lot of space to do these steps. So I'm just going to do what I got to do, okay? So I've got this matrix, 1, 3, 1, 8, and then 0, 1, 0, 2, and then 0, 0, 1, 3. And I'm really close to solving this already, okay? And I'm just going to use my last couple steps up in the corner to get x and y, or x all by itself. So the next thing that I would do is this. I'd use this third row right over here because of those zeros in that one, and I'm going to get rid of this one right over here, okay? Because no matter what I multiply on to row number 3, these zeros are not going to affect like the 1 and the 3 over here. So it's not going to like ruin the nice stuff that I've got over here, okay? So what I'm going to do is I'm going to take row number 3, I'm going to multiply it by -1, and I'm going to add it on to row number 1, okay? And that should get rid of this, like this 1 right over here. Okay, let's see if that's the case. I'm going to replace row 1 with that. All right, so here's what I end up with. Ready? So row 2 and row 3 are going to stay the same. 0, 1, 0, 2, 0, 0, 1, 3. All right, let's see what happens with row number 1. So I do my algebra over here off to the side. So I've got a negative of row 3. So that's -0, -0, -1, and -3. And then I add that on to row number 1. 1, 3, 1, 8. All right, and here's what I get. I get 1, and then 3, and then 0, and then 5. So I've got, I'm just going to write it down. 1, 3, 0, and 5. And right now, here's how my system of equations works. I'm really, really close using Gauss-Jordan. Watch this. This is how it looks so far. So that first equation, 1305, is x, so 1x plus 3y plus 0z is equal to 5. And then my second equation looks like this. It's 0x plus 1y is equal to 2. And then for my last one, I have 0x and 0y, but 1z is equal to 3. Do you see this? I'm really close to solving. I just got to get that x part all by itself. So here's what we're going to do. Ready? To get the x part by itself, I need to get rid of this 3 only. And the row that gets rid of only the second column stuff is the second row, because I've worked with it in such a way that, the zeros around that 1, the 1 will only affect stuff in the second column. So like that 3 or that 0, if I wanted to do that, it won't affect anything else, okay? So what I'm going to do is I'm going to use this 1 over here to get rid of this 3, okay? So the way that I do that is I would take row number 2, I'd multiply it by -3, and then add it on to row number 1. And that's going to be my brand new row number 1. And you're going to love this because it's going to solve the whole entire thing for us. All right, so here's how we do it. Ready? Row number 2 times -3. Let's do the algebra off to the side. Oh, wait. I'm already falling a little bit from my protocol. Since row number 1 is the only one that's going to change, we're going to keep row number 2 and row number 3 the exact same. Okay, so let's see what we get for row number 1. So I'll do my algebra off to the side. -3 times row 2. So I'm going to take 0, so all this stuff, multiply by -3, so I get 0, and then -3, and then 0, and then -6. And then I'm going to add that on to row number 1, which is 1 and 3 and 0 and 5. So if I do that, what do I get? By adding them together, I get 1, and then -3 and 3 is 0, 0 and 0 is 0, and then 5 minus 6 is -1. So here's what I end up with: 1, 0, 0, -1. So now here's how everything is looking so far. If I retranslate this into equations, the top equation is x is equal to -1. The second row is going to be y is equal to 2. And the third row is z is equal to +3. This is my solution. Once I get it down into this form, where it's all ones and zeros, this thing is called an identity matrix, then that means that I've completed my Gauss-Jordan elimination. Oh boy, so that took a long time. I figured that that's probably going to be my the video. I'll finish it up. That's 6B. But that's Gauss-Jordan elimination. All right, I'll see you in the next video, and I'll probably wrap up this page. All right, see you then. Bye-bye.